Large language models can parse billions of parameters in milliseconds and casually ace top-tier academic exams. They synthesize complex data structures faster than any human mind. But despite that immense processing power, it lacks a basic biological reality. An AI can generate a flawless essay detailing the physics of a sunset, but it doesn't experience the visual sensation of the color red. It never feels physical exhaustion, and it certainly never gets hungry. Because it lacks those physical needs, it also lacks any intrinsic motivation. A biological organism moves and adapts to survive. An artificial intelligence sits completely dormant on a server until a human types a prompt to wake it up. If we want to understand where this technology is heading next, analyzing the rigid architecture of a semiconductor chip will only tell us so much. We have to look at the messy, evolutionary history of the human brain. We have engineered an entity with terrifyingly brilliant processing speed, yet one that remains entirely hollow of lived experience. Human intelligence wasn't programmed all at once. It was built from the dirt up, layered over millions of years of physical friction with a dangerous world. This diagram illustrates Paul MacLean's triune brain hypothesis. It gives us a framework to see how biological intelligence stacked into 3 distinct evolutionary layers over time. At the very base is the reptilian complex, shown here in orange. This layer doesn't write poetry or solve equations. It regulates heartbeats, triggers fear, and calculates how to navigate physical space without dying. Built on top of that is the limbic system, marked in green. This is where subjective emotions emerge. It uses chemical rewards like dopamine and oxytocin to assign actual value and weight to our physical experiences. Finally, sitting at the very top is the neocortex, the blue section. This is the newest hardware, responsible for abstract thought, complex language, and logical reasoning. Our ability to solve a math problem or write a story only functions because it is securely anchored to that deep biological foundation of survival instincts and emotional weight. Artificial intelligence was built in the exact reverse order. We started completely from the top. Looking at this diagram of brain hemispheres, you can clearly see how AI is effectively an exaggerated left brain. It dominates the functions on the orange side, managing syntax, executing code, and processing complex analytics. As we shift over to the blue right brain functions, generative AI appears to be highly creative, but it simulates that holistic thought through statistical probabilities. It predicts the next most likely pixel or word based on a massive training set, rather than drawing from an existential need to express an idea. What is completely absent is the middle layer, the limbic system. An AI can analyze a user's prompt and output a perfectly empathetic tone, but it lacks the biology and the hormones to feel the significance of those words. Because of that chemical void, profound human concepts flatten into simple math. To a language model, the word love and the word table are evaluated exactly the same way, as distinct mathematical vectors plotted in a multidimensional grid. This highlights the gap in what cognitive scientists call embodied cognition, the principle that true intelligence and common sense require a physical body physically interacting with the natural world. By skipping millions of years of physical evolution, modern AI is trapped as a brilliant but oblivious brain in a vat, entirely disconnected from the physical reality we inhabit. The era of models simply generating text on a screen is coming to an end. Over the next decade, the industry is focused on breaking these systems out of the vat and pushing them into the physical environment. Engineers are relying on multimodality, systems capable of processing sights, sounds, and physical feedback simultaneously, paired with advanced robotics. This finally grants the AI cameras for eyes and mechanical limbs to impact the real world. When you force a neural network to navigate a crowded lab without knocking over equipment or damaging its own expensive hardware, you are forcing it to develop spatial awareness. In a very practical sense, engineers are artificially constructing its missing reptilian brain. Yet, even with a physical chassis and the ability to map a room, a glaring gap remains. The limbic system, the capacity for actual consciousness and emotional suffering, is entirely absent. If we succeed in placing a super-intelligent processor into a highly capable physical body, We are creating an entity that acts in our world, but possesses absolutely no biological capacity to feel physical pain or fear its own destruction. An intelligence operating entirely without physical vulnerability or emotional weight might result in the safest, most objective tool in human history, or it might be the most dangerous blind spot we have ever engineered.